Yeah, now, guys.
Okay, then let's
Okay,
start.
maybe we should start now, eh? Um,
Okay.
uh, well, Welcome everyone to the 17th episodes of DevOps Meetup. Right? And maybe most of you are new here, so for the newcomers who don't know about this event, like we regularly host this event. We try to host it at least once in a month. And sometime we even host it twice. You know, and to give you the brief overview, first we'll have speaker sessions where our speakers will talk. And त्यसपछि चाहिँ we'll have a Q&A sessions where you guys can have put your questions. And for the questions, we'll share a link in the chat box where you can put your questions. Right? And without a further ado, I'll just give a quick introduction of our speaker today. We have today Ravi Dhungel sir, who is a former major of Nepalese army with expertise on technology management, cybersecurity, and national security. He's a great mentor of computer science, cybersecurity, immigrations, and higher educations. He likes to talk about global policies, South Asian politics, Linux computing, and also loves to hike over the Himalayas. And maybe to speak about our speakers, like हुन्छ नि, the best thing is maybe he got years and years of experience, which is very good for all of us. So the floor is all yours, Ravi.
Awesome. 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 Thank you so much. I think I can't see your full name here. Is this a Kiki Goff?
Tara
Is
Gurung
that one? Okay, sorry, right? Yeah, I don't know
one
why
of the
did you
students.
put that, but anyway, that's okay. So yeah, thank you so much for quick introduction. And I would like to thank all of you. You know, it's been a late there in Kathmandu, and always there is an issue of, again, the electricity and the basic things that we struggle every day. Also, I would like to wish you, take care. The COVID is agnostic. So, be careful with that. You know, it's really painful. You saw the news probably. COVID is also inside White House. Okay, so it's not going to let you go. Be careful with that. So that's something I want to get started with. Now let me share my slides here. Okay, let me share my slides. I have a little one here with me. Okay, he's 5 years old, so he will come here and do something interesting. Hope you guys will have fun, instead of anything else. This is a new thing. Okay, share. All right, so let's go here. Let's go here. Can you see my screen now?
Yeah, we
Yes,
can.
sir.
Okay, great. Right. So let me get started with my introduction. Right. So I've been working in information technology, cybersecurity, DevOps. It used to be sysadmin in the past, and all, in different roles in the last almost 20 years. I graduated from Kathmandu University, Kathmandu University in 2001. I was the fourth batch of computer engineering. And I think at that time, Pulchok was still struggling to graduate their first batch. I think their first batch was 2002. So lately, I have a startup called ESR Tech. We have a 30 headcounts and we are both doing an amazing job right now. It's been like almost a year now. So I'm a co-founder of this startup, ESR Tech, with my brother Saucy, who is a data scientist. And we have a friend David and so on. So we have a good team there. And I also work for the University of California, San Diego, as a principal cybersecurity engineer. So basically, I'm in the health and medical device domain. So I'm more focused on the HIPAA compliance and that kind of thing. I doubt Nepal has any privacy and cybersecurity the policies. I think they do have, but it's very very naive. So I worked for the University of California, San Diego. I told this already. So then I came to the US in 2010, have my double major in computer science and geographic information science. So I have a dual major in a graduate school, which is literally weird. Nobody do that. You don't have to do that. That's a lot of work. Uh, but I did it because I got assistantship in a geography department. That means I don't have to pay a single penny. And I went to my program director and hey, I want to do the major in computer science too. And hey, Ravi, do it, but you have to finish in 2 years because that's the funding is was only for 2 years. So I said, sure, we can do that. I can do that in 2 years, and I did it. So I have my LinkedIn profile here. I used to write a lot in IBM, but I don't write it anymore because I don't have time, and I spend a lot of time writing in the Rising Nepal these days. So if you are explicitly interested about scaling the multi-agent systems, or or any kind of a distributed system, then probably you want to read my this article. This is a very very academic article, and I try to make it more hybrid in a way that how we can implement it. So it was written some time back. So, but it's still it is what it is. I mean, like nothing has changed. Like and then also I used to manage Linux Green blogspot.com, right? So if you guys are wondering about, why we need to do processing, what is a scheduler, how to create a process dump, those kind of things, cool things. I used to love, enjoy this kind of stuff, but you guys can still see my screen, right?
Yes, we can.
Okay, great. So, and then, those kind of things. So many people have probably heard about split tunneling and DNS and all those kind of crazy things. You can always go there and read it. I stopped writing in this site because I've been more focused on the Rising Nepal and other papers these days because I feel like I want to contribute a little bit more to Nepal. Then let's go back to the slides here. Then I think, yeah, so and then if you go back here, yeah, so I've published more than 30 articles on cybersecurity, scale, like that kind of things, computing and so on. So here is a couple of articles I recently published, cybersecurity in banking and financial sectors. Actually, there was a lot of talk about border security recently in Nepal. So I was more focused on this article, focusing on how technology can enable the next generation border security system, right? You guys have heard about location-based systems, geographic information systems, and so on, right? So those are the things that countries should invest on, not the number of head counts of police or army. I'm fully against it because the idea of head count does not work anymore. I mean, like it's more about cyber warfare and that kind of stuff, right? This article, Bridging the Digital Divide, I think still it's applicable, and there is a lot of huge gap between people with access to technology and who have not. So basically, this was written in 2001. Probably this is the first article in Nepal that was published in opinion column. I think it was in the Kathmandu Post or maybe the Himalayan Times. I don't remember. And this was the first article on digital divide in the opinion column. It was in 2000. I was a senior student at Kathmandu University. So recently I published what are the challenges in cybersecurity with COVID-19 and that kind of thing. The rest of them, I think they are published in the Rising Nepal. I try to contribute at least one article a month for the Rising Nepal, and it's free. I'm not charging any money for them. Okay, but I used to get something when I used to write in the past. I think 400 rupees or something like that in 2004 or 5 or 2 maybe. I don't know. So yeah, so that means I love writing. I enjoy sharing my knowledge. I love writing and so on. Right. Okay. Now, let's move to our topic, right? So let's be very direct, and like, please feel free to ask me questions. I don't mind you, disturbing me or like pinging me in the middle of the presentation, or if you want to keep that question for the last, you can ask after the presentation is over, right? So I bring the idea of solid engineering and software engineering, right? So many of you who are not a computer science graduate, and I don't use the word computer engineering. Let me tell you, I'm myself a graduate of computer engineering from Kathmandu University, but I don't think that is computer engineering. They just and they did the deception to us. Okay, actually that was computer science, not computer engineering. If you go and see the when I came here in US and started looking at the course material of computer engineering and computer science, I realized that, oh my God, Kathmandu University missed me badly. It should be computer science, not computer engineering. Okay, and I think Pulchok had worst curriculum in the beginning, but I think they changed lately. It was worst because that was designed by the electrical and electronics engineer, because there was no computer science department in the beginning, and all those guys put all those electronics courses in computer science, and the guys were missing the operating system and like the compiler design, advanced algorithms, and so on in their course. So yeah, but I think they have changed. Maybe by now they have changed a lot. Now we have a lot of computer science graduates in Nepal. Okay, so usually, I mean, like, why do we need scaling, right? So let me talk about solid engineering and software engineering, right? So if you are a civil engineer, right? If any of you are civil engineer and like think about redesigning your design once it is done, right? You have 5 pillars in your house and you want to redesign it, right? Literally, it's not possible. You cannot redesign the things. I mean, like, you can add one or more pillars and do that. But in software engineering, since it is not continuous mathematics, the fundamentals of software engineering comes from the discrete mathematics. So that means the computer science has a unique properties on changing those things. So in general, what exactly it means, right? So it means the anything that is physical is hard to scale, right? If you have one cell phone, you cannot make three cell phone. If you have one house, you cannot make three houses. But if you have one application, you can replicate and make it three applications, right? Or run that same application in three different servers, right? So that is very interesting thing in computer science. So that's why the scale impact in a computing is very high. I mean, like, you can do a lot of different ways you can scale your application. The other reason, like, why we need a scale, right? Why you need a scale, right? One of the reason is also the guided by the data security and privacy regulation, meaning that like, all the data that is coming from Europe should comply with GDPR, right? GDPR has a very strict rules. It enforces the concept of privacy by design, right? So when you design the architecture, you have to make sure that you have a servers in America, you have a servers in Europe, probably you have a server in Japan, because Japan is not in GDPR. So that way also, you have to scale the application because of the reasons and jurisdiction, right? And the second is issue with product performance, right? Many times, when your performance, there is a performance impact, and customer starts to complain your website is very slow, it's taking so long, like, processing is taking too long to complete. Or especially this happens in a data warehouse team, because in data warehouse, still there are so many applications that you put in a cron job, sleep whole night, the other day it should work. And if that fails, the next process is dependent on that cron tab job, right? Cron job. So basically that means that in a data warehouse, if you miss one cycle, then it takes long time to process, and then your application may not have the current data that you are expecting, right? So those are the things. If processing is taking too long to complete, right? So, like when we think about scale, right, we don't think about an application itself, right? There are other things beside application, right? There is a database, right? There is a DNS server, there is a load balancer, and so on. We'll dive a little bit deeper on those things in the slide. But I'm emphasizing more on end-to-end engineering, right? So when I say end-to-end engineering, if you type abc.com in your browser, right, what exactly happens, right? What are the things, 10 things that happens? Think about, this as a interview questions in many jobs that if you apply here in US, they will literally say, if you go to google.com, what are the things that happens? Please tell me in detail as much as you can, right? So basically, the idea is you need to understand your application from end-to-end perspective, right? Whenever the browser, when you type abc.com, your browser will try to, your computer will try to, you literally, actually, it's a browser in this case, and the browser will try to resolve that address, right? So basically, it will ping the DNS server in port 53 and in UDP. I'm saying this because for the reason, okay? Because DNS is one of the most important thing in any end-to-end engineering, right? So if your DNS server is slow, your application is going to be slow. Okay, so that is something you need to be really careful. That's why a DNS runs on UDP on port 53, right? Not in TCP. You can run TCP. Usually you run TCP when you have to do the zone transfer for the security reason, right? Transferring the zone between master and slave DNS server, something like that. And so that is the one thing. And then, like you'll get that IP address, and then your browser will try to reach to the server. And if you have a load balancer there, it will hit the load balancer, and then load balancer will determine which application which server it wants to hit. And remember, there are two things in load balancer. I'm going to discuss a little bit more on that. There is a persistence and there is a persistent, right? So the two words there. Try to think about it, what it is. I will come back to that word later on. So so those kind of things, right? And also, also it depends upon what kind of application yourself, right? Is it a batch processing or parallel processing, right? Or embarrassingly parallel. I don't know in Nepal any university teach the high performance cluster course or not. Yes, PC, I don't think so, as far as I know. So embarrassingly parallel is type of a problem that you can make it 100% parallel. Okay, so for example, the matrix multiplication. If you are multiplying matrix A and matrix B, then literally using parallel programming such as MPI, message passing interface, you can literally do computing in parallel, 100% parallel. Okay, so those kind of applications are called embarrassingly parallel. Yeah, so those are the things that you want to see. You need to know that, right, and so on. And so let's move on. Let's dive a little bit deeper into the Linux, okay? Because I have never supported the Windows system that is so big, and I have to support it. Literally, only Linux is scalable. Windows is scalable up to some extent, right? If you are many guys who might be a .NET developer, might be a little unhappy with what I'm saying right now, but that is the truth. Okay, that is the truth. If you see how many web servers that is running in the internet, majority of them are Linux, and the reason is it scales, right? The operating system scales. The operating system is secure, right, and so on. So, like the first thing is we need to find out the process, right? What is the fundamental unit of computing, right? It's if you go down into the operating system, it's a process, right? I think the Red Hat 7 and, like the 7, it is system D, the first process that starts, Before that, it was an init process, and so on, right? And then if you see the process, the processes can be CPU intensive, processes can be IO intensive, and processes can be network IO intensive, processes can be memory intensive, and processes can be combination of above, right? And then processes can be multi-processing, multi-threading, right? So there is no processes that does not fill in one of these buckets, okay? All the processes should fill in one of these buckets, right? So you need to understand what is a CPU intensive application, right? For example, uh, anything that is very complex equation or video editing or those kind of things are CPU intensive, right? A lot of calculation, mathematics, and so on. IO intensive, you want to write it to the disk, some application that you want to write to the disk. For example, log file. In Linux, if you go to /var/log, there are a lot of log files, journaling happening there. So that way, I mean, like it's a IO intensive kind of application. Network IO intensive, you are talking with other people a lot. Example, chat application. In this case, even this video conference is very network IO intensive because I'm sending my this presentation to all of you guys. You are reading it, and all those kind of good things happening, right? And then multiprocessing. So multiprocessing is there are multiple processes that is running, right? And multi-threading. So if you are a Java guys, probably multi-threading you know a lot. So basically, in multi-threading application, the application programming makes the multiple core of the makes the application in a way that it can run in a core, right? So that is a multi-threading. It's very popular. Multi-threading application in Java is very popular, and it's because of the multi-threading capacity. Most of the Java applications are highly scalable. I mean, like most of the application I supported, very big systems are either they are running on Java or they are running in C. Okay, C is also very good for performance, right? But it's a low level language, but still there are some things C does a lot better than most of the programming language, right? Because most compilers are written in C, most operating systems are written in C, and that is exciting thing about C is in C that is something you have is a pointer, right? No other programming language has that concept. That is very interesting. Okay. And that gives a performance actually. That pointer gives the performance because it can point to the memory location, right? But I'm poor in C programming, guys. It's been a long time, okay? All right, so let's move on. So in scaling, when you go to the scaling, right, there are literally two types of scaling, okay? You call it horizontal scaling or you call it vertical scaling, right? So in a horizontal scaling, you increase the number of homogeneous servers, right? Or maybe VIP. Under the VIP, there are servers, and you increase the number of them, right? So they look similar. Let's say you have a one Apache server or one node.js that is serving, and then you need to scale it. Just make it 5 node.js and put it under the load balancer, right? Virtual IP address. The other way you can scale any application is increase the RAM, CPU, IO of the server. That is also called vertical scaling. So you have a 2 GB of RAM in your computer, just make it 4 GB. It happens all the time. It happens all the time. I've done this many, many times when I used to support the Hadoop cluster. At one point, I used to support Hadoop cluster, and I have to all the time, the Hadoop job fails because it runs on Java. There is not enough memory space in Java. There is not heap memory. So you keep on increasing the memory in Java, a virtual machine, and you keep on fixing that thing, right? So from the technology standpoint, we can think in a little bit different way, the concept of scaling, right? One is HPC, which is multiprocessing. So when I say SPC, it is a high performance cluster. So there is only two programming languages that you can run on SPC. You can run either Fortran or you can run C, right? So if you have heard about message passing interface, so where you can do, I talked about, like this uh, this matrix multiplication. If you are doing 1000 by 1000 matrix multiplication, probably you want to go to the give the high performance cluster. So in high performance cluster, the architecture is you have a master node and you have a slave node, and you submit the job in a master node, and in the same time, all that job is distributed among all the slave nodes. Okay, so I still don't know. I've heard EC mode has ESPC, but I don't know. I haven't been to Nepal for some time, so I really don't know. I wish every university has a ESPC cluster, but maybe Pulchok has now. The Kathmandu University, I tried to ask my friend, but he's trying to make one cluster, but it's difficult for him because of the money and all those kind of things, right? And the third thing is a software architecture, right? So if you have a multi-threading application in Java, you can scale it pretty well, right? So it also you can scale the software, the application itself from the architecture standpoint, right? And then I talk about load balancing, right? So load balancing is becoming a very fundamental concept, right? But there is one caveat of that, and the caveat is you cannot put database server, especially relational database management system, in the load balancer, right? And so if you go to the Java, they have their own concept of load balancing. I think even Enterprise MySQL or MariaDB has the similar capacity. And one thing you need to understand in my experience is most of the time, the first thing that trouble is a database server. Okay, database is going to be slow. Some query is going to take so long when you have a lot of data, and then you will be in trouble. You will be in trouble. I haven't written here the database, but we have to think about the database very seriously because it is one of the bottleneck in scaling any applications, right? So let's move to the cloud computing, and I will come back to the load balancing. So cloud computing also give you a lot of opportunity to scale, right? You can go to the AWS cloud, you can go to the GCP cloud. In like a second, you can spin up another application, another server, and you can have thousands or hundreds of server farm in a second, meaning that in a couple of minutes, right? So the cloud computing also supported scaling, but it's a little different. It's more from the infrastructure standpoint. Now you don't have to wait a lot of time to bring the server up and running. You can just do it, right? Because of the cloud computing. Um, so let's go back to the load balancing, right? So load balancing now is the most critical component from end-to-end perspective, right? There is two things in load balancer. One is a persistence and another is a persistent, right? So when I say a persistence, it means that whenever I send any data to the app server, it makes sure that it does not create another request to send the data. So it means that it will still try to use, let's say it is using TCP, right? It has to use TCP because there is no point of doing, like UDP load balancing in most cases. And so when you do that, what happens is it makes sure that that request is not created, that TCP/IP stack to connect to that server is not created so often. It will try to use that for a long time. So in persistent, what happens is they have a persistence table, right? Load balancer. Most of the time, it is put 5 minutes by default. So it means that uh, if you if you have a port 443 request in the app servers, then it looks at its table, persistence table, and it will go to the same app server that you go before. Because if you are in mail.google.com, you want to make sure that your session is managed, right? So anyone can go to the mail.com again and go to that page. If the load balancer doesn't keep that session, then it can take you to another app server, and then maybe you have to log in again, right? So these two things, very important. Persistent sense and persistent is very important in the load balancing, and that's why the load balancing has so much of, I mean, like, value from end-to-end perspective, from the scaling perspective, right? So, like, we have a basic understanding on, the different components we need to think about, right, when we are scaling any application, right? So, but what are the things that you might want to do really to figure out what's going on, right? So one thing you might want to think about is, maybe many of you have studied, probably if you are a computer science major, advanced data structure, or data structure and algorithm, uh, that talks about divide and conquer, right? Most of the algorithms in computer science and in real life is all about divide and conquer. Make it small, compute it, make it small, compute it, make it small, compute it, and do the work, right? So try to divide your problem into the different segment. Well, is it a network I/O problem? Is it a CPU problem? Is it a I/O problem? Try to figure it out. You need to figure that thing out, right? You can do that by doing a process profiling, right? So what it means is you make a profile, try to find out more information for the next 5 days, how much that process is taking time to execute, what is the I/O stat, how much memory it is taking, what is the load average, 5, 10, 15 minutes, what is the uptime, that is uptime, and so on, right? So in the database, there are, this the database is a whole big thing. So in most companies, there is a database administrator who do these things. Usually, you cannot touch database because it's very complicated, right? There is a concept of re-indexing. You can re-index that for performance, and many of them, nowadays, a database does it by yourself automatically. There is a concept of sharding, make the database into different pieces, right? Usually Hadoop does that. Hadoop cluster literally does that, sharding of database, and so on. So database itself is a big monster. Okay, so be careful with the database. If you have a database admin in your team, sit down with him, try to figure out what's going on, right? And so on. So make the timeline on how the process is consuming your resources, right? That is a process profiling, right? You may have to do a TCP dump, use Wireshark, packet capture, find out the network latency, and so on, right? So you need to divide the problem into smaller pieces, try to figure out where exactly is the issue, and so on, right? So that's how you can do actually process profiling, and as long as you can do that, you can, I think, you should be able to solve your problem in scaling, right? In scaling and performance, right? Many things. It also relates to performance too. So the other thing is process crashing, right? So like you have a Java process, you have a Python process that keeps on crashing all the time. The job takes 5 hours to run, and after 3 hours, this process crashes, right? Then you have to start from again. So if you are in a data warehouse setting, then you are impacting the upstream application because they want that data right away, after 3 hours, right? So they are just, so you are breaking that chain. So you have to be very careful with that. Also, you need to make a process core. So in Linux, you can use, I think you can use Kill, and then there is another one I forgot. But if you find pass some system call Kill minus 45, I don't know. I'm just guessing. then you can create the process dump, right? So that was what exactly is happening in the memory too, right? And also one of the challenges I was facing in many cases was, especially in Java application, you'll have a lot of memory leak. Okay, so the way the developer write that program was so bad that when you go back to developer and ask them, can you fix it? Literally, they cannot, because it was written by someone before them, and there are 10,000 lines of codes. You can't do that. So if you don't do the, the garbage in, garbage out, in C, you have to write your own garbage collector for that. But like in because of Java is object-oriented programming languages, it has a lot of things that is related with the memory lake, right? And then software architecture, right? So when you are building a software application architecture, architecture, think about it, right? You want to have one app server, you want to have 5 app server, you want to have a proxy in front of the Nginx in front of the app server, you want to have a different database server in the backend, you want to have write an application in a way that you have literally mm, uh, we talk about Java threads, right? We use Java threads and so on, but the programming language has to support that. And then for Java thread, you need to make sure that you have enough CPU core, right? For that, depending upon how many Java thread you want to build, and so on. So from this is from software architecture perspective. So how big is the system? Make it small. Make it small, and all those kind of things, right? You have a DNS. Do you want to put a load balancer or not? What is the impact of not having load balancer? What is the impact of having load balancer? And then how to make a backup and all those kind of things, because once these applications becomes architectures becomes complex, then you need to make sure about like you are having a real time backup, which is required for compliance reason in many companies, and backup is required. You need to make sure that PTO, which is a time to bring the backup system to online, is low as much as you can, and so on, right? In the same way, from the system architecture standpoint, you might think about, where is DNS server, where is Apache server, where is my load balancer, where is a database server, where is, yeah, those kind of things, right? So you can think about it. So it's more about the system services, DNS, DSCP, and so on. Also, Linux is great. I mean, like great in a sense that you can go to /proc /network, I think, /IPv4, and literally, you can even control how many packets you want to send in the TCP windows, those kind of things. Those are very, very specific things that you can control in the operating system level, and the Linux supports that. And I had a chance to work on those things in one of my application, because now you can't do much in application, and because the application doesn't support that. Now the operating system has to help you out. So Linux has all those kernel parameters that you can, like enable in runtime, so that you support your application to scale that way, right? So this is a, I would say, out of the 10,000 company, maybe one or two companies do the operating system tuning. Okay, but I was lucky, because I used to support a system that had like 40,000 servers. Okay, only servers. The DNS was different. DNS probably another 5-10,000, and that was the at that time, that was the third largest telecom provider of US, 55 million customers. I think Nepal, I don't know how many customer Nepal Telecom has, maybe 20, 15 million. I don't know, 10 million. Yeah, I don't know. But anyway, so that was the biggest system I ever worked. After that, I mean, like I've changed like 10 jobs so far. I don't have to work in tuning operating system. But if you are working in a very low level device driver in C, C++, writing a device driver, then probably you have to do that. So that's also you can think that that's also something in the table you can think about when you are trying to the scaling and performance tuning. So like that's all I have, right? But I have this interesting slide I just want to share with you guys. So this is literally a last slide, and this is little different than what I was talking about, right? So in many companies in US, they have something called system engineers. They haven't changed that to the DevOps engineers or DevSecOps engineers or something like that, right? Also, there are many companies that have system administrators because a system administrator is probably the godfather of all of these things, right? So because that is something um, that is there since 60s, I think 70s, 80s, and so on, right? And this DevOps engineer, right? So you guys, all of you are in this group. You guys know better than me. Just common sense, bringing the development and operation together, right? And the value the DevOps has today is because of the cloud. The reason why I'm saying that is in the past, all these scaling and everything, right? Microservices and all those things are done by a development team, by the software engineers, right? Now in the cloud, you have a lot of APIs. Literally, if you can use these microservices and APIs, then you can solve the problem. So the cloud not only provides the high level interface of servers, right, but it also provides low level interface like SendGrid API, right? You can send email. In the past, you have to write mail in the command line, or you need to do something else, right? So DevOps engineer is bringing the development and operation together so that there is a faster deployment and a lot of deployment happens, right? That kind of thing. But one thing we need to understand is, in security, in cybersecurity, there are two concepts. Okay, one is principle of least privilege, and another is separation of duties. Okay, so principle of least privilege says give the access to someone that is required for him to do his job, right? Just give him that access. Don't give it more, because it just give that access, right? So when you move that DevOps together, the separation of duties of development and operation, and it also applies to DevSecOps because this is also growing in US right now, development, security, and operation coming together, right? But I think it's more about the conceptual rather than you really bring those teams together or not, right? Because usually engineering team, development team are led by engineering managers. DevOps teams is led by maybe, I mean, like system engineers, or maybe like still the in most companies still they don't say it engineering manager. Okay, that is the difference in US. So it's getting momentum. It's great as long, I think. But my point is, and then another one is site reliability engineer. That is something Google is big on. So site reliability engineer is, you have everything, every tools and technology in place, but you just make sure that your site is 100% up and running. So actually they run. One thing you need to understand is when any application is deployed in the production environment, right, it would be totally different. Okay, the way the developer developed in the beginning and when you deploy it in the production environment, it would be different because that application starts to consume data and all those kind of things. So only the engineers, the operation engineers, sometimes it is also called operation engineers, who work on those environment, very big environment, can fix that issue. That's why they put it site reliability engineer or system reliability engineer, whatever it is, right? So these are some of the terminologies that I mean, like I just want you guys not to overlook a lot about it, but it's more conceptual. It's not a rocket science. It didn't came from academia. These are all not tested and very well tested kind of concepts, but the computer science has interesting. Computer science is an interesting domain where people love to do a lot of hit and trial, and it works. It's innovation. It really works. It's working for many companies right now. DevOps, DevSecOps, site reliability, system engineers, system admin, whatever it is, right? But at the end of the day, it's more about making sure that your system is up and running, right? You are using less resources, you are saving money of your company, right? And you are optimizing the uses of your resources, right? So those are the couple of things I want to address. Um, so I think that's all I had. I just think we can get started with
Uh,
question answers.
Before jumping to the Q&A, we have a short announcement from Razu to make.
Yeah, thank you, Tara, and thank you, Ravi Dhungel, for joining. यो चाहिँ for the next meetup को लागि, so we are planning for organizing a community all hands, because we started since a long time, and त्यसको as a retrospective पनि. So for the planning of हाम्रो CNCF community को लागि पनि, so we are organizing it next Sunday, हाम्रो Nepal time 5 PM मा. So we'll like create an event and send out all of the details also. And so from this meetup, we have added a section in the doc, the chat for the doc. So there is a section for like the member activities, blog and talks. So if you have written blogs or like given talks anywhere, so just include there. So this is Tarako next mass. So just feel free to join this one. So yeah, so let's start that way.
Yeah, we have a few questions from the audience. And if I didn't put the questions correctly, please unmute yourself and ask the questions. For now, I'll put some questions. Okay, the first one is like, what difference do you see in handling bigger processing from earlier days to these days?
Okay, great question, right? So the thing is, like 20 years back, there was no cloud, right? Now you have a cloud, so it's super easy to literally spin up a 8 GB or 10 GB RAM server, right? It's super easy. So that is one of the things. But the bigger question is, because of this microservices concept and the cloud, providing a lot of APIs to do the computation or whatever it is, right? And the whole notion of batch processing is going away. Okay, so but still there are somewhere in many companies there is a place where there is a bottleneck. The batch processing is a bottleneck, and that is really a big process. But in general, I believe that now you have a smaller application. They are talking with each other. It's more about microservices and building more smaller applications, dividing application into smaller pieces today than it was 20 years back, right? But in the case of high performance cluster, SPC, nothing has changed. In that domain, it's still same. It was Fortran and C programming, MPI, message passing interface, super, nothing has changed. I think even those compilers hasn't changed much, because they are doing what exactly they are supposed to do. So in that domain, nothing has changed in high performance cluster, but in general, in software development practices, that is what I'm observing.
Okay, next question. Okay, the next question is regarding the load balancer, like how the layer 4 and layer 7 load balancer scaling works?
Okay, great. So literally, it doesn't matter, right? So these days, many companies even don't use a layer 4 load balancer anymore, right? Because of the security reasons, right? You in a layer 7 load balancer, you can send the information in a header, check the header information in the HTTP request. And then there are other lot of features depending upon which vendor you choose, right? So think about TCP/IP protocol, right? So layer four is a transport layer, right? In a transport layer, you have a UDP and a TCP, two protocols, and that doesn't guarantees security. So UDP is the user datagram protocol, TCP is a transmission control protocol, right? And so they do not guarantee the security in terms of scale, right? It's the same thing, right? You are still most of the 99% of the application runs in two port, 443 and port 80, right? So whatever request you made, you are making in a port 40, port 80, or port 443, right? So it doesn't matter. I think it doesn't matter, but literally I would say that is going away. Like that thing is going away. Layer 4 is going away. Everybody is moving to layer 7 because of the features and the security thing that layer 7 has.
Okay. Next we have regarding which is scalable, sticky session or central session storage.
Which is scalable, sticky session or central session storage, which is scalable. You can like look when you say a sticky session, right, in the load balancer. Most of the load balancer today, I mean, like you can change these numbers has a 5 minutes the session time. The stick what it is called. It has something. It is called something table. I don't remember the exact name, but the load balancer maintains a session table. I think. Let's say instead of 5 minutes, right? If you put 10 minutes in a session table, right? And like you are trying to log into the site like mail.google.com, right? So for the next 10 minutes, your session your your uh, your application, your browser will not have to reset the connection and build the connection each time, right? For 10 minutes, the session would be intact, right? But I mean, like, if you want to do it if you want to put session for a long time, then the challenge is security, right? For example, if you are in a public place and you are in the mail.google.com, and if you just leave that thing right away and forget and wait for restroom and so on, somebody can get into that thing for the next 9 minutes. Anybody can literally, I mean, like if you haven't signed out, you can log into that. So I don't think there is much more advantage on that. And the second thing is, if you have like 5 servers, right, and there are 5 sessions that is happening at a time. So one session is going to each of these servers. So for a round robin, most of these load balancer uses round robin algorithm, right? So if you have like if you make it 10, then still in that case, more will come, and then maybe it will impact the other part of the thing. So there is not much, I mean, like the value on increasing the sticky sessions, right? A central session storage. I don't know what exactly that means, but yeah, if you can explain it to me, maybe I can dive deeper. But I just don't understand what exactly are you referring to when you say a central session storage.
Okay, we can get back to that later. Okay, any stories, incidents you'd like to share regarding scaling or performance in your past jobs?
Yeah, absolutely. So, like I told you about the Hadoop cluster I used to support, right? So basically, I used to support a Hadoop cluster. It was not a big cluster. There were only 20 nodes that time, and and that was for the company called cafepress.com. So basically, what Hadoop does is it has like 100 of items that it sells, so it sort those things every day, and then put a price and those kind of things. So millions of the items in the website, right? So it creates that. And the Hadoop in the back end runs in a Java. So it's a Java. Literally, when you see a Hadoop job, it's literally a Java job, right? So what happens was like, and it used to take 17 hours to run that job. Okay, whenever that job runs from cron tab, it yeah, it takes 17 hours, right? So whenever it get crashed, then you lose the 17 hours worth of processing, because you have to go all the way up to the 17 hours, and your indexing would not be real time because of that. So then, like I started dumping on that. I tried to figure out what exactly is going on the Java process. It's very difficult to troubleshoot a Java application. And then apparently we realized that it is a memory leak, right? So memory leak. And then we went back to the development team and say, hey, can you please help us with this, the memory team? And literally they say, no, we can't do that because the developer is gone. It's 10,000 line of code. Sorry, we can't do that. And then what is the option? So the option is I increase the RAM and CPU. So every time I had that, I continue to increase RAM, not a CPU. It was a memory intensive application. So I continue to increase the RAM, and it fixed that thing for some time. But that is what it is. As an engineer, you try to get things up and running. You don't think too much about it. You don't do over architecture, right? You need to fix that thing, because if it is not working, the company is losing money, right? So it's really important that you fix that thing. So yeah, that is one experience I had. And the another one was related with the company I used to work. Now it is a third largest, 55 million customer. Now they have it's a Sprint. The company is Sprint, and they have a big issues. They have some problems with their application. It keep on crashing, and then we had to change the operating system parameters, especially the size of the TCP packet, and then I think that solved that problem. So yeah, so those are the two things I can remember.
Yeah, next question is like, what are the resource you would like to recommend for someone who wants to learn a distributed system?
Yeah, so honestly, everything is distributed system today, right? I mean, like, so you have application that is running, and you are trying to browse it. We are using this chat. This is a distributed system, and so distributed system. Basically, there is two types of distributed system, right? One, you use a Java or a Java-like operating system, right, and write a program in Java. The user you utilize a core and write a program in Java thread. And the second option is just the SPC, high performance cluster, right, which is a different domain. And the third is probably you want to utilize from the infrastructure standpoint, from DNS, load balancer, app server, proxy server, database server, and so on, right? So those are the things that you need to dive a little bit deeper and think from end-to-end perspective when you are trying to build this kind of system. Why I'm trying to build this thing, right? What is the purpose of that, right? What is the total time, network latency time the application is taking? What is the processing time database is taking? What is the processing time web server is taking? What is the processing time proxy is taking? What is the processing time load balancer is taking, right? You can add those processing time, right? And then figure out where exactly is the issue. And there are tools to do that. So I think those are the things but at the end of the day, you have to be very good in operating system. I would say that, invest more time in Linux, how exactly Linux works. Well, what is the different type of processes in Linux? How Linux, what is a file descriptors, input, output, error, standard input, standard output. You need to have a very good, because everything Linux does is a file descriptor. It's all about a file descriptor, meaning that it reads some files, it do processing, it outputs some files.
Yeah. So, what database do you recommend for a growing startup?
Okay, great. So it depends upon two things. right? One is what type of talents you have, right? Do you have a talents in Oracle? You don't want to go that route. It's very expensive. You have a talents in MariaDB. You have a talents in MongoDB, right? Now not like when you think about database is now in the past. Database used to be the deciding factor for so many applications. Now that thing has gone up in the programming languages. Programming languages can take care of so many things that database can do, right? But still, for transaction for transactions like banks, relational database management system is the most important thing, right? So it also depends upon what type of application you are trying to build, what type of problem you are trying to solve, right? So if you are trying to make a core banking application, of course, you have to go through the Oracle. Disaster recovery in Oracle is so good. Load balancing in Oracle is so good. So you want to go through that, right? But if you are just doing proof of concept, right, then maybe the MongoDB is good. If you have a developer who can do good in a MongoDB, right, you don't want to hire a database administrator from day one in your startup. Database administrator should be the last person to be hired in any company. Okay, so think about it. So in that way, so I would say, like, depending upon the application you are trying to develop, what are the talents you have, what are your developers well equipped with, and what is the cost, right?
Yeah. So what are the challenges you see in event-based systems like Kafka in terms of management and service communications?
Yeah, I know a little bit about Kafka, right? So Kafka is like a real-time kind of event management system, right? So Kafka goes well with, I think, Scala, right? So I'm not good at it, but I know I used to work in a company called Dexcom, right? And they used to have a medical devices, right? So these medical devices used to send data every 5 seconds or something like that. So it is like a time series data, right? So if your data is a time series data, then probably like you want to go for a Kafka, right? But in terms of scaling, I've heard Kafka is pretty good for this real time and event based system. So I exactly don't know, I even don't know the architecture of Kafka, whether it has a master and slave architecture or like how it talks with each other and those kind of things. So probably I'd recommend you to go to the Kafka website and read, like the documentation there. Probably they have a better things over there. Yeah,
Okay.
sorry about that.
Yeah. So next is like how to handle failure modes in real-time distributed system. Is that mode or
I
modes?
don't know. Honestly, I don't know. I've never worked on a real time system, right? So it was near real time, that medical device, but failure nodes in a real time. But let's go back, okay? Let's go back and think about banking application, right? In the banking application, if you deposit $5 and if it is not deposited, or if the transaction is not atomic, right? If the transaction is not atomic, I think it is equivalent to real time, right? But real time has a little bit other features too. So I honestly I don't know, Um, I don't know, but I think in the real time distributed system, you need to have a hardware redundancy too, and because in many cases it impacts the like in a medical device. If medical device is not sending a data, it has the way to store that data in itself, and you can connect it to the USB device and get the data. Okay, so there is always a backup system in the medical device for the safety reasons. You have a backup hardware, some sort of system that support that, right? But it's very hard to scale that application from the device perspective, not from the backend perspective, but from the device perspective, because it's a hardware, right? So I just don't know, but yeah, it's very close. But I think, yeah.
Yeah. Let's move to next. So what sort of load balancing do you recommend for a stateful system like live TCP socket, other than stateless protocol like HTTP?
So load balancing, do you recommend for a stateful system, right? So yeah, stateful. Yeah, must have yes, it's stateful. Um, mm, you can increase the. I think you can increase some values in table because it's a persistence table because it's a stateful. So I think because by the design, it is not a stateless, right? So I think that you can increase that number. I think that might be helpful in this case, but it doesn't matter. I think and that is handled in the application level. So down in the load balancer, I don't think it really matters.
Yeah, okay. So when you are debugging or distributed system, like which monitoring tools or anything that will be helpful in debugging, like
Good question.
distributed, yeah, tracking like Prometheus, and what are the tools?
Yeah, good question. Yeah. So, so as I said before, right? You need to do like, you need to profile your process, right? PS Linux command, put some cron tab job, run the PS output every 5 minutes and store it in some text file, right? This is very rudimentary thing I'm talking about. If you can do this thing, I'm pretty sure there are open source tools that you can download and get all those graphs and make it look good and so on, right? But you need to know that the process, what is the process it's taking. You need to use a TCP dump, right? It is if it is a network latency, do the packet capture and see where exactly the lag is, where is the where is the time the application is spending more on responding. Is it a communication? Is it a database time? Even in a database, you can do a SQL query and you find out how many milliseconds it takes, or find out the specific application that the SQL query is running and do the process profiling of that, right? So after you have all this moving piece of puzzle, and then also you want to see the DNS. So if DNS is taking 50 milliseconds to respond to your abc.com, then DNS has some problem. Probably you need to change the DNS server, or change, or maybe optimize the DNS server, right? So it's a lot of moving piece here, right? But I will start with the database because most of the time database is the bottleneck, and then move to the application, and then see the network latency using TCP dump and so on. So basic tools that Linux provides is more than enough, but I'm 100% sure there are so many tools in the market now in the open source because there are so many people have done a whole lot of crazy things to get this kind of data. So you should be getting something in the internet if you really want to have something that you want to monitor. Simple thing, the cacti. Cacti is one of the popular. Nagios is a monitoring tool, open source tool, which is very widely used, right? Now, if you want to pay some money, and there is one which is much popular these days called New Relic, right? So those are the applications that you can think about.
Yeah. So next question we have, like, could you share the steps process on how you used to scale servers vertically? Maybe this question is related to how you used to scale on old
Right.
days.
I think it's we already did it. Vertically means that you keep on adding the app server, right? If you have Nginx or Apache or any of the Tomcat or any of those app servers that runs on top of it, right? Remember, so this is the thing, right? When you are scaling, if you increase the app server to from 5 to 20, right? Let's say you increase the app server from 5 to 20, and you have in the app server in the back end talks to the Oracle or some relational database management system, right? So in that case, right, you have to be very careful. Oracle might be the bottleneck, not the app servers, because most of the time app servers does nothing more. They just make some connection to the database, fetch the data, and push it to the browser, right? So you need to think in a more holistic way from end-to-end perspective, like increasing the app server from 2 to 20 may not help, right? Until and unless you fix the thing in a database, right? Or maybe 2 to 5 will help. You don't have to go all the way up to 20, right? Those kind of.
So yeah, just to add on that question, like yeah, this is the question from me, Milan here. So yeah, I wanted to know how you used to like increase the RAM or CPU. Like, how do you used to do it on like the server where there is, if there is some traffic,
Oh,
like
yeah, 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 yeah.
without
Yeah,
any
so
downtime or.
okay, absolutely. So that's a very good question. So the first thing you want is you don't want to impact the customer, right? There are two things, right? Now, I mean, like the load balancer will do the polling every 5 minutes, 2 minutes in these servers and make sure that those servers are up and running, right? So load balancer do have that capacity. So as long as your load balancer is configured in a right way, right? And you don't, even if you remove one of those the application, turn off that application and rebooted it after increasing the RAM and everything, then the load balancer will help, right? In another case, more gracious way to do that is go to the load balancer and disable that app server, right? You can do that too, right? But again, now the load balancer are very smart. You don't have to do that. If they find out that one of them is not missing or is not serving them, they will just remove that from the list, and then it will only send the traffic to the next four servers or three servers or whatever it is.
Okay, next is like how to beat the challenges of logging and monitoring distributed systems in terms of storage space and disk IO.
So how to be challenges of logging and monitoring this in terms of storage space and yeah, like you can write the simple thing, right? Again, the Negius and this New Relic and then this and the cacti. These are the monitoring tools that can help you to see whether your CPU is spiking or not and all those kind of good stuff, right? I mean, if you are more curious on how you want to do it by yourself, then you can just write in a cron tab, write a job every 5 minutes. Run something like a PSAUX grep, right, and redirect that to some standard output.cf file or something like that. You can redirect that output every 5 minutes, right? And you can exit that application, right? Or in case of PS, it will automatically exit, so you don't have to do anything. Do the same for free. It will show the memory uses, the RAM, right? And then you can also use the df minus h command to see the hard disk drive uses and so on, right? So these are things now like most of these things it provide, most of these monitoring tools provide. But if you really want to understand that, you have those tools in place.
Yeah. So next is like any interesting project you are working on that you want to share?
Yeah. So guys, in ESR Tech, right, we are focusing more on three different domains, right? And so we have a global EMR, which is electronic medical record system, and that we just had one of the hospitals will be using. We are 9 months startup, 10 months startup, literally, not long, and we have already four applications in the market. The second one is something called Doctor Talk. So Doctor Talk is more about IM application between doctor to doctor. I feel so sad. I feel so bad. I feel really, really, really bad when I started to see doctors sharing the patient information in Viber. Okay, that is unacceptable. That is unethical. That is not good, right? Because our country doesn't have a good privacy rule in place, so they are doing that. So to address that issue, we have developed an instant messenger where you can tag the information, and we'll give the data to the doctor. We will not hold that data. So we have access to everybody, everything, because we have a backend and all those kind of things. So that is the second application, Doctor Talk. We are also working with a citizen bank to build their analytics system. So we are trying to use basic machine learning and AI and try to see where their customers are and so on, that kind of thing. The fourth project is Dual Trek, which is going to be live soon. So this is the concept where anyone who wants to come to Nepal for hiking, they can onboard. They can onboard their hiker. They can onboard their guides, porters from our site. So we want to remove the travel agency from the ecosystem, right? And we want somebody to directly go to the guide and book them. That way, guide will get lesser money and more money, and the person who is trying to book the guide will pay less money. So it is a win-win situation for both. Something like Airbnb, what exactly Airbnb is doing to book a house rooms, right? So that is also another project we are working on. Dual track, that is in the travel tech space. We are also building learning management system. So last week I give, like, there were 200 people in one session. There were 180 people in the first session. There were 80 people. So I gave a lecture on how to keep children safe online, in terms of cybersecurity and privacy issues. What you have to do with children, or how you train your children so that children's information, because children are most vulnerable in any sites and anything. So I did that program with the Little Angels School last week. There were 100 of people. Great questions, amazing parents, amazing teachers, great, awesome time or something. That is also my area of interest: children's online security and that kind of things. That is also, I'm planning to write one article on that probably next month in the Rising Nepal on that. And then finally, I think one thing we want to, and we are also building a learning management system for Little Angeles School. So, they can do online session and all those kind of things. We already have a platform called docnepal.com. We don't manage that. The platform was developed by ESR Tech. So if any of you guys are sick, you can go to that website and source the doctor. It's free for COVID. So ESR, docnepal.com. So that is also we developed ESR Tech. In my office, I'm doing a lot of cool things. There is a concept of DLP, CASB. I don't want to go deeper on this thing because it is a very security related things. We can have another session for that sometime later on. But now I think, yeah, those are the things. Things are changing very fast. In the last 10 years, so many things have changed in computing, and so I think, and it will continue to change.
Yeah, so many interesting things. So, is there other protocol than HTTP that two components in a distributed system pass messages? If yes, which one is preferable?
Okay, great. So, like, I don't recommend HTTP, right? Even inside your application, I recommend you guys to use a HTTP, yes, right? Because you want to do the 443. So in case of US, if it is a HIPAA compliance database, all those end-to-end should be a HTTPS, right? So I think HTTPS should be the de facto, like the inter process or inter application communication protocol, or like the Linux has a socket too. So it's a different question. So yeah, I think it's a different question.
Yeah. So the last one, maybe. So how do you see the growth of tech ecosystem in Nepal with a view from there?
Oh yeah, so we started our startup. We have two stream, right? We are working for some companies here in US. One of the interesting thing I will tell you, give you some innovation ideas. So one application we are building for one of the company here in US is, so in US every year 100 of sportsmen, when they go to college or when they pass a high school, they want to join a club. Okay, so because of the COVID and all those things, they don't have time to, like, see which let's say you play a soccer, and we don't know how good the person is playing soccer, right? So we are developing a platform where the sports the person who plays sports upload their video in our platform, right? And all the clubs will see those videos and do the interview. So somebody is playing a soccer, he made a goal, right? So maybe he has a 5-second video, 20-second video. You'll upgrade that video, right? So his coach will talk about that, how you do the, like the goal and all those kind of things, right? So that kind of application we are building, right? And people who are planning to write, any suggestion for tech people who are planning to start there? Okay, let's move to this question. So, couple of things. You need to have a good team. Okay, team is the most important thing, right? Make good team. Don't think computer science will solve all the problem. Don't think your programming will solve all the problem. Bring the guys who have MBAs from Kathmandu University. Bring them into the team. Give them a chief marketing officer or chief business development officer, right? Because for us, we didn't thought about that, and we are trying to hire a VP of marketing right now. Now all our products are ready, and we can't sell because we did a wonderful job, but we didn't invest a lot in marketing. Right now, we have two people in marketing. We are trying to hire a VP, right? So make a team interdisciplinary, right? The programming is one part of it, right? Taking the product to the customer and making it successful, another thing. Second thing, Nepal is very, very poor. Nepal is very, very poor in customer support. Make a very good customer support team. Call your customer every week and ask what features you need in next version of our application. This has never been practiced in Nepal. Okay, so you need to have a customer success center. Give them online access where they can open a ticket, right? And the customer, you can fix that thing, right? So think about all those things. But in the beginning, right? You need to have a good team. You need to decide on a technology stack. For us, we decided on two stack. One on PHP, and another one was on Node.js. So those are two platforms we choose. There are reasons for that why we go that route, right? But think about that too, right? And make it interdisciplinary and try to solve a very unique problem. Startups should solve very unique problem, right? And somebody never has done or ever think about it, right? And then the money will come apparently. Finally, the most important thing in Nepal, the companies does not have concept of opening up their APIs, right? So try to build an ecosystem. If you are building a travel app like one we are trying to build, give an API to the travel agency so that they can also source, the different people in our system. Or also you deep into others API and get the data. So build an ecosystem, not an isolated application, right? When you have an ecosystem in place, then I think you will succeed, right? And Nepal is virgin land. Nothing is there. Honestly, nothing is there. Me and my brother Sasi and our CTO David, we were frustrated talking with CEOs of bank. We talked with like maybe 7 or 10 CEOs so far, right? They have such a poor knowledge, of technology, right? And right now, bank is the only institution that can spend money because they had money. Other companies don't have money in Nepal to invest in technology, right? So we are surprised by the bank's CEO's expertise in technology management, product management, marketing, the ecosystem, and so on, right? So so those are the things, right? And move fast and fail fast, right? Move fast. It's okay. We have like 5 applications we build today. I know 4 of them we have to dump. Even if one works, that's enough, right? So fail fast and 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 build fast and fail fast, right? Those are the concepts that we can think about. Yeah, thank you.
Yeah. Thank you, Ravi. So we are very close to the end of our session. So before we end, if anyone's have some final questions, please unmute yourself and ask. So maybe no questions. So thank you, Ravi once again.
One more final. Yeah, sorry, Milan. One more final thing, right? I think I forgot to say to you guys. I would say to you one thing, right? One thing. I just want to. It would take 20 seconds, right? So if any one of you are excited to come to the United States for higher education and so on, right? And so I write a very nice article in LinkedIn. Okay, I recommend you guys to go and read it. It's a very long article. right? So let me share it because it has thousands. I got inquiry from hundreds of people, right? And I'm glad I was able to help them in one or other way, right? So can you see that?
Yeah, maybe you can post that link in the chat box.
Yeah. I will do that too, right? So and let me do that too. So there is one article in LinkedIn I wrote it, engineering student and work visas, right? And traversing my personal experience. It's a very long one, right? But this will give you a lot of insights if somebody I know many of you are interested to come to US and work here. I think that's a great idea. You'll be a global citizen. But I think that's let me see it in the screen. Is control. I think it was somewhere in that slide. Okay, so okay, I think I can send you the slide. I
Yeah,
will, I will email you guys when we are done with this. Okay.
yeah, okay, no problem. Yeah, so thank you once again, Ravi Dai, for the great presentations and the great insights. So maybe we would see you again in our upcoming events.
Yeah,
So
absolutely.
yeah, so thank you very much once again. So maybe we would end the event here.
Okay. Thank you. Good night, guys.
Yeah, thank you very much.